Gonna give a presentation. I think that this style of R packages, we've all interacted with R packages, but you may have never, like in terms of loading libraries and using dplyr and using tidyr and using bioconductor and other packages like that. But I'm sure a lot of you have never actually dug into one and looked at the files and what's there. So before we start doing that, there will be a little bit of live coding. I'm going to give just a little bit of a presentation about why I like to use this organization scheme and what it could do for you, and then also just a little bit about it. And then there'll be we're going to make a really, really basic R package together as a demo. And then hopefully we'll take a little break, go to the bathroom and get some water. And then if we have time, I'm going to share one of the projects that I've been working on and I've made into an R package, and just kind of walk through my workflow a little bit so that we can have both a simple demo that hopefully everyone can really understand, and then also go through something a little bit more complex. So you can, I think we won't be able to go through my code line by line, so you won't understand exactly what the code does, but a little bit more to think about how you might want to implement this in your more advanced projects. Okay, so I'm gonna attempt to, share my screen, which is probably going to be the biggest challenge of today for me. Okay, so here's my screen. Now we'll put it in full screen, maybe. Okay, everyone can see it? Yeah, good, cool. Yes. So today I'm going to talk about R packages, which is a file system standard for R software. I sent out this link on the bottom. This is Hadley Wickham's kind of scheme for an R ecosystem. If you like the tidyverse, then you are familiar with Hadley at least a little bit. And R packages are something we use all the time, but it's also a way that, and we think of them as something that you use in terms of, if I'm going to make a package, it would be something for many, many other researchers to use my functions and things like that. But you can also sort of repurpose it for your own project needs. So first, what is a file system standard? It's basically a way to organize your files so that someone, either your future self or a new person, can come in and know where things are. This purple photo is a Linux file system standard. So Linux always has a boot, which has all the startup files. It always has a bin folder, which has all of the binaries. Your home folder will have all of your home directories. It can have a media folder and external drives. And as you can see in these photos, maybe your files are currently organized like this, and you spend all of your time trying to find things. Now, while my R files are really well organized, this happens to be how my house works a lot. And then I'm like, why can't I find things? It's better to be like this. So that's where we're going to try and go today. So why is it useful? It's really easy to get disorganized. I'm sure everybody knows that. And organized files let you find things faster. I'll find, especially if I'm like chatting with someone or doing like virtual co-working, they'll ask me, oh, do you have code to do this? And I'm like, I do. And now that I'm a little bit more organized, it's so much easier for me to just seek that out. And if you don't organize your files, nobody, including yourself, knows what any of your file names mean, or what they do, or why they are where they are. So another reason it's useful is maybe you feel like sometimes you open an R project you haven't been working on and it's like a trash fire. And if you need help, nobody wants to help you fix your garbage that's on fire. But if you organize your garbage, you can make more garbage and spend less time figuring out where to put it. So what is this system? There's that whole instructional ebook online. What I will say about the ebook is that it's definitely focused for like package developers, like folks who are trying to make the tidyverse or vegan or a package that's like redistributable and for people to use in a generalized way. So there's a lot of stuff in there that might not be of use to you, but it does have a lot of good components. But one of the reasons why this system is good is because many packages use it. And so if you start using it for your own work, it can make you more comfortable with going and looking at digging into other packages. Like if you find that you're trying to run something and you don't have a dependency, but you don't really need that dependency, now you can kind of know where to look and see if maybe you can modify things to make it work for you. And then RStudio was built to understand this structure out of the box. It works really well with GitHub and GitLab integration. And then kind of nobody's really come up with a better system yet. I think there could be better systems, but they don't exist. So now you might be wondering, how do I make something like this? There's 5 basic components of this, and you already have some of these. So if maybe you don't use functions yet, but one of the small things I hope to do today is encourage you to realize that you can write functions. It took me a long time to realize that I could write functions. And then you have data and you have scripts. So you already have these things. It's your code. What you don't have is this documentation and the metadata. So we'll talk about 2 R packages today in terms of making packages yourself. Interestingly, you need a package to make a package. But one of them is Roxygen 2. And I think in the email I sent out, I told folks to install this. This is a special package that makes your documentation for you. It just uses a special annotation, and we'll look at some of that together. And then there's also some special metadata files that keep track of what you're doing and are helpful to future you and also collaborators. So where do things go? I'm gonna walk through some examples of what these file directories look like. But your functions will go in the R folder. Your data will, surprise, surprise, go in the data folder. Your scripts and markdown files will either go into an exec folder or a vignettes folder. Documentation goes into the man folder or the namespace file. Metadata goes into the description, the README, and your rproj file. And don't feel like you're like, oh my gosh, there's so many things. We're gonna go over these elements like over and over today. So now I'm just gonna walk through what is where in the package that I'm hoping we get to look at today, which is a package that I've made for a project looking at biocrust recovery following disturbance. So my scripts go in the exec file, exec folder. The exec folder is a little bit less common, but I use it. Scripts go in it, so it's kind of, you can use it within the package and it's saved within the package, but it's not like you won't see an exec folder in like the tidyr package because they don't really have scripts in that package. It's more so functions and utility for you to use. But if you're making a package to, do a data analysis for a research project, you will have the exec folder. It's probably what I interact with the most. So all my scripts go there, like scripts to make figures, scripts to run models, all of that kind of stuff. All of my functions go in the R folder. And one of the nice things about making functions in this style of package or in a package is once you build the package and you load the library, then your functions are there and you can like tab autocomplete them. You don't need to like load them into your environment every time. And then your data goes into the data folder. I like to work with R data objects and RDA data objects, and we'll talk about that a little bit today. I always keep my raw data, in its raw form elsewhere, and then I kind of slowly bring that through a pipeline. And though as it goes through the pipeline, it gets saved as data objects, which are then incorporated into my package. And then to open your package when you want to make new scripts or do whatever you need to do with your analysis, it's just you open it like you would open an R project. I'm sure a lot of you work in R projects. So that's how you open it, and that's how you can interact with it in that way. You can also interact with it in your README. READMEs, while incredibly underutilized, are very important. Unfortunately, what I'm going to show you today is my underdeveloped README. I think it's something that it's really good to have completely fleshed out at the end of a project, but while you're starting to work on your analysis, maybe you won't have that much information in your README. Your libraries go in the description file. So the description file, by libraries, I mean other packages that your package depends on, or dependencies. So like in my package, one of the things that for all our packages, DevTools and Roxygen are dependencies. So they'll be listed in that description. Roxygen puts all of your documentation in the man folder, and then it also puts it in the namespace. So if you open the namespace file, which we will do eventually, you'll see the dependencies there as well. The git ignore shows up if you use GitHub. And now we're gonna walk through sort of this same file organization structure, but in an actual R package that people use other than me. So this is tidyr. You can see it's different than my structure a little bit. There's some of the same stuff there, like the data and the R folder, but there's no exec folder because, as I talked about, there aren't really scripts in tidyr. So the functions are all, if you were to want to edit a function in tidyr, you could open this R folder and edit it. All of the markdown files are in the vignettes. So if you've ever been interacting with a package and you want to learn, they have some examples and stuff, those are often vignettes, and they'll be markdown files that are often exported to HTML, and you can open them on the internet. I use them a lot, or read them a lot. The scripts would go in the exec file, but here there probably aren't any scripts. All of the data, so if you've ever worked with the Iris package, or in R with some of the, I think there's also that one with all the cars, MT cars, all of those data objects are in the data folder in that package. Again, Roxygen puts the documentation in man and in the namespace file. And then you can open the tidyr package and edit it using the R project. The description has a bunch of information about the libraries. There's also a README, which I haven't actually looked at it for tidyr, but I'm sure it's got a whole bunch of information about the package. And I think that's pretty much it here. Yeah, and then these GitHub, git ignore, and this GitHub folder show up if you use GitHub. All these purple things are just other stuff you might see in other packages, like the licenses. I mean, I probably will have a really basic license on my package, or maybe not even, whatever the Creative Commons ones is. I guess since I'm USGS, there might be something more complicated because it's government, but those are just other folders that can be there, but they're maybe not important to you. Mostly I wanted to go through a package we're all familiar with, just so you can see that while there might be additional stuff, the structure is similar. And then everything else goes into this, my mouse, this Insta folder, which we'll talk about a little bit.
Michaela, I have a question.
Yeah.
About rbuild ignore. Is that also GitHub, or is that something we would interact with?
That's not something you'll interact with. It's that. So when we make a package, you'll see there's this build and reload process that we do. And I'm pretty sure the rbuild ignore, I actually haven't really interacted with it, but I think that it has to do with that. But I'd actually have to look into that to say for sure, but it's not related to the GitHub stuff. So you might be wondering, do I really need all of this for all of my code? And the answer is no. So it's just another tool. And if you're doing a really small project, you might not need it, and you might just want to make an R project and have code, data, and outputs. That's something I do for really simple things. But the bigger your project gets, the more collaborators involved, formal schemes like this can become really useful. So that's all I've got for the presentation. And we can take some general questions, but I think if anyone has any, but I think if you're like, oh, I'm so confused, I think as we start going through it together and actually trying to make a package, stuff will become a little bit more clear.
I'm kind of curious. I just tried to follow where you were and went to my tidyr on my computer, and it doesn't look exactly like yours. Is there
Okay.
any, do you know why that would be? Does it matter? Maybe it doesn't
It
matter.
might be different versions. I'd have to see like how it looks different. I might be working with an old version. That photo was like, this presentation's been used for other things. So my photo might be older than yours. How did it look different?
Well, I'm not going to be able to tell you all the different things. They're different file folders though, and then there's no README right off the bat, which I thought was weird.
Yeah, that is strange. I have to look at it to say, but
Okay, maybe it doesn't matter. We don't have to do
yeah,
that.
I mean, I mostly shared that just so that you can start like this approach to organizing your research projects. I'm using the word project and I don't want you to think of it as an R project, like your research. Like this is sort of to try and match these packages that you also interact with. And that was kind of why I went through tidyr. I'd be interested to see, yeah, it could be a different version, or I don't know, there should be a README. That's strange to me.
How do you even get to look at tidyr in your console? Do you just
You don't go in the console, you go in your file explorer and you have to follow the path where all your packages are stored, and then you can look at it.
Okay, great.
Okay, so before we move on to the next part, the only thing that you're going to need is this simulated data. So I have a Google Drive link to that I just pasted in the chat. So everyone should download that and then just move it to whatever file directory you want to work in for this, like where you want to make your example package.
Can you repeat, Michaela, you said do they need to download all of that or just one specific?
I think that hopefully that should just be a link to a CSV file.
Okay.
Yeah, just the CSV file. It's 2 columns. It's not any real data. I just made it up for our purposes. Okay, I'm going to share my screen again. And this package that I'm sharing the wrong screen. This package that we make together, I can send it out I can send a version of it. Where is it? Can you guys see my console, or is it sharing the wrong screen? I don't see the green bar.
Yeah, it's visible.
Okay. Usually there's like a green square around it. So this is the package that I want to eventually show, but we're not going to work on that first. So the package that we create, I'll share the directory in an email afterwards. So if for some reason you just want watch and follow along, but you don't necessarily want to do it yourself, that's fine. So we'll go into file and we'll go into new. We'll put it in a new directory, and then we want to click our package. The package name will be Wise Demo R. And then just make sure, so I have it in my, my internet connection is unstable, surprise, surprise. I have it in my April R workshop. So just make sure that you have the file path where you want this to go. And then if you check this, it'll create that git ignore and make it a Git repository, which we can do for now. So it's going to switch to this new project or new package. And then it has this R project within it. It's kind of in some ways like an R project plus time to think about the differences of those. Okay, so anytime you make a package, the first thing you'll have is this hello.r file that'll come up, and that just you know, this super basic function hello world, where if you run the hello function, it will print hello world. I'm sure if you've tried to learn functions before, you've run into that. So here you'll see there this rbuildignore, the description, which for now is pretty basic. When I go through my package, I'll show this and it'll have a little bit more information, like I'll have my name here, the package does, and all those types of things. That's what the description file is. There's the namespace, which will have, well, right now it's not actually anything because we haven't built the package, but that's where all the dependencies will go. And then in the R folder, there are the functions, which right now is just the hello.r. So we need to make some new folders. So the first thing we'll do, oh, there's a man folder, which has the hello in there as well. So we'll make a new folder, and this first folder will be data.
Hey, Michaela, can you just increase the size of your RStudio?
Yes.
It's a little hard.
Yeah, I always forget. Is that better?
Yeah, and then could you increase the text size?
Yeah, I can zoom in a little bit maybe. Is that better? I always run into that problem
that's
when I'm
good.
watching something on Zoom, and then when I'm on my own big screen, I totally forget about it. Okay, so we have the data folder, and then we're also going to create one folder, which is going to be the exec folder, which is where all of our scripts will go. Except, yeah, okay, cool. Okay, and the first thing we're going to do is create a new script. So we'll go, maybe if it lets me, file, new R script, and save it. And we want to save this in the exec folder, and it's going to be called pre-process.r. Cool. So the first thing that we're going to need to do is load some libraries.
Sorry,
we'll
Michaela,
load-
could you go back to the pre-process saving?
Yeah, I just
Found out.
saved. I created a new R script and I saved it in exec, and it was just a blank R script called pre-process.
Okay, great.
Okay, so we're gonna load DevTools and then also Roxygen too. And if you have those installed, they should, like as you saw, they kind of like came up as I started typing. So we'll load both these packages. The DevTools package loads use this, which is another package that we'll use, but it's part of that. So then you're gonna wanna read in your data. So this is that I had you download. It's called example data. And then you wanna put your own file path here. I'm just gonna copy my file path for the interest of time. Gonna put it to this simulated data.csv. So we'll load that, and quickly we can look at it and see that it's just two columns. One is group and one is score. And then we're gonna want to apply pre-processing. Oh, I'm not, there we go. So and then we're gonna wanna save the cleaned, so we're not doing pre-processing, but let's say that you did. And then we'll save that cleaned data in the required, I can't spell, package location. Okay, and so we'll do that using useless, but we've already, I'm gonna write it out the verbose way. So if you haven't loaded a package, you can write out the package name, double colon to access functions within the package. And the function we're gonna use is the use data function, which is really important. You'll use data a lot. And then the is called example data. And I'm setting it to overwrite equals true. So that means if I come back here and I do, like, let's say before we save it, we did a bunch of pre-processing. We removed all of the weird stuff, the NAs or whatever it is that you do to pre-process your data. So then will run use data. And if you look down at my console, you'll see that it says active project to this directory, adding R to depends in the description, saving example data to example data.rda. And then there's this red dot that says your data. See this if you don't know how to do it. So we can go over into our file explorer and look at data, and now you see it here. And so what we'll want to do next is use this function document, which is in DevTools. We'll press it or run it, and then it will say, this is your first time using Roxygen. We'll update it automatically. This is the version of Roxygen that you're using is written out in the description file. It's loading your package, your namespace, which because we just, when I opened namespace, it looked kind of weird. It says the existing namespace was not generated by Roxygen and it will not, oh yeah, that's something. So delete your namespace that exists here and document again, and you'll have a new namespace file. And this will say generated by Roxygen. We're not actually using any packages to have them in there. You'll see in my version, my package, there's a bunch more stuff. So it'll be in the BioCrust recovery one. But so this general workflow of like pulling in your raw data, doing stuff, saving it with use data, followed by this document command, that's the workflow that I use to create data objects. If you are one of those people who make many scripts where you have this chunk of code that's like cleaning the data up and you copy and paste it every single time, I used to be like that, and now I do this. So I have a organization script where I make all of my data objects. And then my actual scripts that do my analysis are much shorter because they don't have this copy pasted code over and over again that could have errors. And if I need to fix something, I don't have to go through every single script and fix that one line that I copy pasted a million times. I just go back to the beginning of my workflow and fix it.
Michaela,
Does
we
that
have a
make-
few questions in the chat.
Okay, I can't see the chat for whatever reason.
No worries. So Sharon wanted to know, when do you document after each edit, or
That's a great question. So you document after anytime you create a new, anytime you use the use data command to create a new data object in your data folder, you document. Anytime you create a new function, which we'll get to, you document. And after you document, you also go over to this build tab up here. Yours might be down here if your layout's different than mine. And then see this little hammer, you press the install and restart, and you can see here that starts to recompile your package. So now if I were to run, once this is done, it will load my library, and this example data will be, so see how it says library wise demo R. Now if I start to type example data, it's there. But right now you can see there's no information about it. It's there, we can look at it, but nobody knows what that data is. So now we're gonna get to our,
there's a couple
next.
more questions.
Okay, yeah.
So Anna's getting some conflicts with the hello, conflicting with her package, wise demo R.
Okay, you can just delete the hello if you want. That I didn't delete it, but you can go in here and just delete that file because we're not actually going to use it at all.
And another question is, why did the warning come up the first time you did document, but not the second?
The warning that I got the first time that I did document, this about the namespace. So when you create your R package, you have, it comes with a namespace file, but as you could, if it will let me look at stuff. But the namespace file that's generated when you first create the R package doesn't, I don't know why, but it like looks strange. So that when we first created the R package and I made the exec folder and the data folder, we should have just deleted namespace, because Roxygen will create a namespace file that is in the right format and it is in the Roxygen syntax. If you're confused about what the Roxygen syntax is, we're about to get into that.
Okay, and then a final question from Marie is, what's the benefit of using an RDA or our data instead of a data frame or
Yeah, so
Tibble?
I think that the reason that I do it this way is because it's just, that's the file, our data is the file structure that, like RDAs is the file structure that this approach uses. I think I save stuff sometimes as like .r data, or I actually don't think I've ever saved, I don't work in the tidyverse a ton, so I haven't saved things as tibbles and stuff, but this, once you load this data, you can change the format of it however you want. This is just how the package ecosystem structure works.
Okay, and sorry, one more question now from Sharon. I think I might be able to answer this, but do you have to delete the namespace at the beginning of each? Do you have to delete it every time you document or just at the beginning? I think just at the beginning, right?
Yes, just at the beginning. I just missed that step.
Okay.
So that's a great question though. Okay, so now we have something that exists in our package. We have some data, which is super exciting. But we don't, as you saw, we could look at this data, but they're just like when you look at, like if we were to look at the empty car, is it called empty cars? If we were to look at the empty cars object, maybe we'll see. Okay, see if as we load and as we type empty cars, you'll see this data was extracted some metadata about it, right? But for what we just made, example data, I'm getting some weird feedback. So if I start typing example data, you don't see any metadata about what that is. So if I'm like, if you just sent me this and I was like, oh my gosh, what is example data? I don't know what these groups are. So that's where Roxygen comes in to make things a little bit more organized. So now we're going to, again, create a new R script. But this time we're going to save it in our R folder, and it is going to be called data.r. And you always want it to be called data.r. And we'll talk about why in a second. So this file is going to be this is where your metadata is going to go, and it's going to link up with the data objects that you create. Before we do this, does anyone want me to like go over what we just did again? Is everyone good? You can nod if you're good, and maybe send something in the chat if you're like, I'm so lost, I don't know what we're doing at all.
We are recording this as a reminder. So if you also feel like you're just comfortable with just watching this and going over it with yourself at another time, you can do that because we're recording it.
Yeah, and I think when I started working with this file organization structure, I had an example package, and that helped me a lot. So that's one of the reasons why we're creating this, is so that you can have something to refer to. Okay, so the data.r file is going to be in Roxygen notation, which pretty much means every line will start with a hashtag sign. And oh, there is a question. I'm wondering about the warning I'm getting. So this warning, the existing namespace file was not generated by Roxygen, will not be overwritten. That just means you need to delete the namespace file and then run document again. Because when you create an R package, it includes a namespace file, but Roxygen wants to write the namespace file for you. And I think that might be if you make a package and you don't use Roxygen and you do all of your own documentation, then you edit it yourself, but you delete it and then you run document, and then it generates one that will update it automatically. Okay, so the £sign and a single quotation is the Roxygen notation. And for each data object, you're going to write a couple different things. So first you're going to write, and then you write so the @ sign is what pulls in different things for oxygen. So if you ever look at the metadata associated with a function or with a data object, this is how that metadata was written. So the @ sign, and then you write title. So we're going to write the information about this example data. I'll print it down here again. So we're going to write the metadata about this super basic example data. So the title is scores of group A and B. And then the description is going to be like, okay, so I know scores of group A and B, but what is it? And this is going to be really basic just because it's an example. When we look at my code, it'll be a little bit more descriptive, but it'll be a data set with scores of 2 groups. Here is where I usually I'll write, this is a data frame with 10 columns and 5 rows. It was generated using this function, and it is this. This is where I'll put a bunch of information about what that data object actually is for future me or for collaborators. And then we'll do an @ format, a data. So this is another place where you can put some more information. So this is a data frame with 60 rows and 2 variables. And then you can do a little bit more information here. I don't always do them as verbose as we're being here, but we might as well just so folks can be exposed to it, and then you'll see what I do, and you can see shorter format. So here, this is a describe argument. So it'll be item, and this is stuff you can paste in the chat, Courtney and Kendall, so folks don't have to write it all out if they don't want to. Group, so this will be participant A's, participants group, and it's either A or B. Score. And so what this is saying is like four column group. This is what column group is, 4 column score. This is what column score is. I usually just do the title and the description for my purposes, but you can do, I wanted to show you guys the most way you could do it. And then something else that is, to close the brackets, and then something else that you can do is at source. So you can say where you got this data. Oftentimes I'll just be working with my own data, so I don't have a link to it, but these data I actually use from a different example R package, which I'll share at the end. So I can put the source in and there'll be a link to it, but something that you always need to do at the end of this. So even if you just did these two rows, title, line 1 and line 3, title and description, it has to end with a normal line of code without the Roxygen annotation, with a double quotation and the name of your object. So that's how it links this object that you created in your data folder to this metadata.
Okay, a couple of questions coming up. First, there was one a little while ago from Sharon about the fact that DevTools might install our Oxygen automatically, and if so, do we need to install our Oxygen separately?
If DevTools might install it as a dependency, and so then that's fine.
Okay, and so then another one is, how does the data.r file know the metadata you're referring to is example data and not another object you might have created?
So that's what I just highlighted. Line 11 is what links this to it. And I'll show in a second when we save this, and when we run document, you'll see how it works.
Awesome.
So you always put whatever object you're annotating goes at the bottom, and you can have you'll see when we go through my code, which I think we will have time to do. I'll have all of my data objects in the data.r file. They'll just, each one starts with a title in Roxygen syntax, and it always ends with the name of the data object in quotations.
Awesome.
So
And-
Michaela, if you created another data object that you wanted to have a separate description for, you would do this same annotation, but just the at source, it would be different. And then the last line there, like line 11 would be different, but you.
Yeah, so I would just do this whole process for like, let's say we had, I don't know, like demographic data about participants in group A and B, and that was a different object. I would, start here and I would be like, at title, this is blah, blah, blah.
So all the metadata for whatever data you create goes in this data.r script.
Yes. And this is cool because you can look at the data.r file, or so we're going to save it. And then we're going to go back into the console and we're going to type document. We're going to enter, and it's saying updating Wise Demo R documentation, loading Wise Demo R, and then I have a typo because I put 2 curly brackets here. So that's what that warning is. You guys see the warning? You see how I accidentally have double curly black brackets, and it's like, the format's messed up. What's wrong with you? Delete the curly bracket, save it again, run the document. Now it runs without the error, and it also says writing example data.rd. So now we'll go back over to our build tab. Every time you add metadata, create a new object or create a new function, you have to build and reload. If you're just making scripts, you don't have to build and reload, but we'll get to that. So install and restart, it'll do the whole thing. So what this is doing now is it's rebuilding the package, and it's like, oh, wow, there's new metadata here. I'm gonna put that in the package. So once now you can see in my console down here, it's loaded the package. Now if I start writing example data, maybe it will work. Oh, it's not coming up there. Darn it, I thought it was going to come up in the, like it did for the MT cars. Let me see if it does. You might have to do something else to make it come up. But that's how all of this documentation is basically built. But one thing that this does do is now someone who can come and, like, anytime someone sends me an R package that they've been creating and I need to work with data, this is where I go to see like what that data is. Okay, so we've done that part. Now we're going to create a function. So we'll go back. We can leave this stuff open. I guess we can close hello. And we'll, okay. Someone has a question. I'm getting a warning that I need R tools. Yes, you do need R tools installed. That was something that I think I sent out in the email. If you're working with an old version of R, if it's trying to pull the most recent version of R tools off of CRAN, it might not work if your version of R is too old. So that's that happens sometimes, and it's annoying. But so we're going to create a new R script, and we're going to save it, and we're going to save it in the R folder, and it's going to be called functions. So when we get to my package, you'll see I have 2 functions files, but basically this file is just going to be a bunch of functions. It's going to be one because of the interest of time. Function for the R package, and I'm going to make like the most basic of functions, and when I'm writing it out, I'll go over the function syntax in case you've never written one before. So this function is going to be called make box plot, and I usually write, this is just a little kind of style tidbit. I usually write all of my functions out in what is called camel case. So you can see here the first letter of each word is capitalized. That's camel case. And That way, if I start writing something and it's like that, I know it's a function, so I don't get confused. So you're gonna assign the name of this function. You write the word function, which is in base R, and then in the parentheses, the arguments that go within a function. So I'm sure all of you have used a function before. Like if you're running ggplot and you need to tell it what the data is, that's an argument. So here I have data frame as an argument, and then you also need to have the X and Y to make a plot, right? And then outside of the parentheses, I'll have curly brackets, and in the curly brackets is where I actually write the function. So this is just like modifying the box plot function. And I will make functions for plotting. Like if I'm going to make a ton of bar graphs in ggplot and I want them to be all the same in terms of the colors and the size of the font and stuff, I'll just make, and I'll show something like this in a little bit. I'll just make a function with all of that verbose stuff in it with just a couple arguments. And that, I think plotting is a really easy way to start using functions if you feel scared of them, like I did when I first started using them. But inside boxplot, you need to have score and group. Oh wait, sorry, this is, yeah, group. And then your data is going to be example data. So then we'll save this and then document it. Install and restart. So this function isn't really it's just the most basic of things, but it's mostly just to show you how you can have functions in your R package. So now that our R package is loaded, I can just start typing make. Oh, wait. Yeah, I did it. Oh, no, it's not working. I messed something up. Did I save it in the right folder? Functions. I'm trying to figure out what I did wrong. Is anyone else getting it to come up when they run? Maybe it's because I didn't. I'm going to try building and reloading it one more time and see if it works. Oh, duh. So now that's in my environment, that's like a way you can just load a function normally. But let's see if I try again. If it comes here. It's that in the wrong order. Okay, so now it's saying, now that I didn't run the code, which is one of the reasons why it didn't work. It's saying, okay, make box plot masks make box plot, and that's because I have it loaded in my library. So now we'll build and reload, and hopefully I think it should exist in in the library now. Okay. Restarting the session. Sorry about that, guys. Okay, now we have, let's make still in the global environment. But in this one, it exists.
Anna and Inga were able to get theirs to work. So
Yeah, I
that's
think
good.
I think maybe I messed it up, but we'll just move on from there because I was able to make it work here. So I don't know if I saved it here. Because this is, I made this package before so that I knew what I was doing. And I was able to get it to work there. I'll try one more thing and see if maybe it works. And if not, we'll just move on to using the function in the interest of time. Still just my global environment. Well, if you can get it to work like I did in my previous one, has anyone else been able to get it to work, or is it just 2 folks who've gotten it to work? So here you can see that in the package that I made, I still had hello, and then I have make box plot. And so then you can load if the function worked and it loaded into your package like it should, then you can access it here and it just like lives in your package. So now we'll go and we'll create a new R script. And this is going to be trying to use that function. So this will be our first R script or our second R script that's going to go in the exec folder. So we'll save it and we'll go to exec and we're just going to call it boxplot.r. Okay, so you'll want to load your package. Since I couldn't get the function to load in this new one, I'm just going to load the package that I made before. So that one just doesn't have the R in it. So once you create a data object, like the data object that we created this example data, when you want to load it, instead of writing a CSV or putting the whole file path, once you have your package loaded, you'll type in the command data and then double parentheses and the name of your object if you're in the console. So then I'll navigate to my environment and you'll see example data is there. And the promise just means it's lazy loaded. So it won't show you the information, but if you double click it, it will be there. And if you call it, it will load it. And then since I have my package with the function in it loaded, I'll run make boxplot. It also right now I have make boxplot in my environment, but if I'll remove that and run this again. So now I have make boxplot. I ran it, and because I told it, because of the way I had it set up, it just will run it with that data. But you can also fill it out and write df equals. And I'll show some other functions that I actually use that I've written that are a lot better than what I wrote for an example. Equals group. And you run that and it shows you the box plot. So that's just kind of a basic introduction to this ecosystem. So in the description file, again, we'll go through one, but this is where all of your information goes just about the package. And you'll see that this package, because it was created, it requires a version of R greater than or equal to 2.1. You can look at the namespace file. And right now, because I'm not using any other packages, it doesn't have anything in here. But when we look at one of mine, you'll see, like, because I use tidyr and dplyr, those will be dependencies and they'll be listed in there. In the man folder is just an RD file for each of the data files that you make. And that has this was generated by Roxygen, but it adds all of your metadata in, just like that file that or that the documentation we wrote out in here. Okay, and is there anything else we need to go over in here? You'll see the data in the data file. In the exec file are just our 2 scripts, and in the R folder are the data and then the functions that I messed up for whatever reason. So that's all I have for this quick demo, and I thought that we would take questions and then maybe take a break and then go over. I was going to share my package that kind of has the same structure, but just maybe stuff that's more like what you might do. And I can go back through things if folks got lost or confused.
Michaela, is there ever a reason why you would need, like, do you need to be checking in with the name space folder? File?
No, you don't. I mean, so when and this is something when I go through my workflow, I think I'll be able to show, is I almost exclusively work with the exec folder for all my scripts, data, like to look at my data objects, and then this data.r file. I'm always updating that. And then I also try to keep the description, like I try to update my description, but that's something that I think is great if you do right away, but it's always something I do, like, oh, I'm going to send this to somebody. I should update my description in my README. But I think mostly what you'll interact with is the data folder, the exec folder, and then the R folder if you write functions. Okay, so there's a question from Sharon. One of the challenges I'd be nervous about with creating R packages is that the dependencies are always updating, R is always updating, etc. How do you manage this? Is it actually easier to maintain your code when you use a package? How frequently do you find you need to troubleshoot? That's a really great question. And I think to answer that, I'm just going to switch over to my package so I can show an actual namespace and explain that. So if you've ever, I think a good way to think about that is like, if you've ever tried to run a package and it's like, you can't run this because you need this package, and the function that you want to use, maybe some things in that package need it, but the function you want to use doesn't need it. I've gone into packages, like downloaded them off GitHub and remove that dependency and then been able to run it. So I think it can be a way that you can, sorry, this is taking a minute to open, my computer's mad at me. Okay, so let's look at my namespace. Oops, that's all my. So in here, it says the only dependency I have is just the R version. So I don't think that, let me scroll back up to that question. By remove dependency, I mean that, yeah, I'll just like, if there's a dependency in here that's like RCCP and I don't think it, and I don't need it, or like dplyr, you can just backspace it, save it, build and reload and see if the code works, which is just like one of my troubleshooting processes. I think that like R updating and packages updating is always a challenge. I don't think that working in this structure, it can be in some ways easier to deal with that because you can make a new version. So this is like the 3rd version of this package that I've made. So unless you're working with a package that's, like a different R package that is really old and the maintainers aren't actively updating it, it might be challenging. But I think that I feel like those challenges you run into whether you're working in this file organization or not. Okay, then there was another question that says, I'm sure you covered it in the part I missed, but did you create the exec
We
and the
covered
R
that.
folders?
Courtney
Did
answered.
someone respond to it? Sorry.
Yeah, I replied, but I was a little confused because Nancy, you did not have the R folder originally because I did. I had to create exec and data, but
So
R
when-
was already there.
If you missed the part where we created the package, we went into file, new project, and then we did new directory, our package. And when you create this, you should have the R folder, but you won't have this data folder or the exec folder. So you create those folders and then you delete the namespace file. Does that make sense?
Yeah, thank you.
Yeah, and I think, so the dependencies will go in the description file, and I was saying that the dependencies would go in the namespace file, but what the namespace file actually does is it is what exports your functions. And I think that that might have been the problem that I was running into in my last, in the demo where the function wasn't appearing in our environment when I built it when I built it and reloaded it, and maybe that might have been, maybe I didn't load the Roxygen library. That could have been a problem. But if you see my namespace here, there's, you know, all these things, these are functions in my package. And we'll talk about those when we go through my package. But one of the reasons, like if you look at, here's the, yeah, oh, no, that didn't work either. So if you're having trouble seeing your functions, it might be that you didn't delete your namespace when you started your package, and so they're not getting exported by Roxygen. So what the namespace does is it takes all the packages, or takes all the functions, sorry, that you created and exports them so that they live in your package. Okay, so if I understand things correctly, the R package tools itself know exactly what dependency they need, correct? So if you create, the reason why this says it depends on R version greater than 2.10 is because I made it in that. And then you can manually add, like, if your package, so there's stuff in this package that I have that only certain scripts that are modeling scripts require this package, BRMS, which is Bayesian regression modeling package. So I could make that a dependency, but I wouldn't, because some of the scripts require it, but not all of them. So you can update the description file yourself and write, like I wrote all the stuff in here. I wrote my package name. This is this is an analysis for, like, I wrote all that. I made the version, my name, how to contact me, a description. I used the Creative Commons license, and then right now I haven't updated any more dependencies because I think that this is all that I need for now, but you can put your own dependencies in. And what that will do is if someone tries to download your package and use it, and they try to like install it from DevTools, or I mean, sorry, from GitHub, and you have like tidyr is required, it'll just install tidyr for them if they don't have tidyr installed.
There's a question a little further up also about dependencies from Sharon about removing dependencies.
Yeah, I answered that. So by remove dependency, I mean, if I've done this before where I've downloaded, like, not a package off CRAN, but one that's on GitHub that, you know, that has a dependency that I keep getting an error, and I'll just try deleting the line with the dependency in the description file and seeing if I can run it. It's not like, I wouldn't say you should always do that, but if you're running into, like, if you're trying to run something and it's like, this package requires blah, 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 and you can't get that to install, but you don't think it's required, you can try doing that.
Sneaky.
Yeah, it is sneaky. It's worked for me before, because sometimes there'll be a dependency that, you know, is for a particular function, but it's not for all of them. So, but generally I don't, besides writing my own dependencies in, I don't think that's something that you need to interact with too much. I think to get started with using this approach, you need to understand the description file exists and think about, like, writing data objects, writing metadata, and that kind of stuff. Do you have any other questions? Okay, so how does everyone feel about taking a 5-minute break, and then I'll go through my workflow a little bit here to just kind of further explain how one could implement a package structure in their own workflow. Sound good? Oh, I think I got a message. Sounds good. Cool. So we'll have some of them. So my package is called BioCrust Recovery. The type is package. The title, it only can on the one line. If you make it go down to the next line, it will throw an error.
I think we're having just delay in your either. Oh, looks like Michaela's internet connection just turned out. She'll be back.
I'm here. Can you guys, did I disappear? It like just like blacked out, and then, yeah, we're actually getting some rain, which we haven't gotten any rain in a long time. So
You could also, Michaela, you could try maybe turning off your camera,
yeah, I can do that.
and that might help.
Okay, but folks can still see my screen, right?
Also,
Yeah.
I just started the recording, so if you could just go back. Sorry.
Well, I mean, I
beginning.
didn't really do anything, and then I got kicked off Zoom. So, okay, so we're gonna first talk about the description file, which we talked about a little bit, but I'll go over it. So this is auto-created when you create a package, but you have to fill in the details. So the first line is your package. My package is called BioCrust Recovery. When I load it, like loading a library, it will be BioCrust Recovery, and it'll come up in my options, as you can see in my command line. It's a package. The title, I could have just written BioCrust Recovery there, but for some reason I also put kind of the same as the description. This title has to be one line. If it goes on to like line 4, it won't work. So basically it just says this package is analysis for a manuscript, and then the name of the manuscript. The version, so I started with, I think, 0.01 or something, and now I'm up to version 1 because I've changed it a lot. I've been working on it for about a year. The author is me, the maintainer is me in my email. So if someone wants to interact with it, or if someone reads my paper, they could, and it's like, I want to try running your analysis, they can send me an email. The description, it just says, the package contains all analyses for the manuscripts, including scripts for all figures and misspelled supplemental figures. This license that I have here is just like a really basic one. You can use different licenses. That's something you can look into. The encoding, lazy data, that's where earlier where it said promise equals true. Dependencies, we talked about a little bit. I haven't really put any in here, but then it does say that it's using Roxygen 7.11. So this is just kind of your overview of your package. And then I also have a README file. So this is just something that if I sent this to someone, they could open it up, and there should probably be more information in it. It just has some basics about this data came from two of our projects. This is where they are. This is what's in the data. It's mostly community composition data. These are the treatments. And then I could have more information about like the analyses I did and stuff in here for folks to read if I wanted to. So now we'll go into my data folder, where you will see I have a lot of data objects. And you're probably wondering how, maybe you're not wondering, but I'm hoping you're wondering how I made them. So we'll open this. So I'm going to try and like navigate through everything as I show it. So here in the exec folder, which again is where I keep all of my scripts, I have, so originally when I made this package, the scripts were like NMDS analysis, this analysis, but once I got further along, I renamed them like figure 1, figure 1B, just for for publishing sake, so people could navigate easily from the paper. So that's kind of where the versions come from too. But we're going to look at this initial data organize. So one of the things about these data was they were entered each. So if you've ever done like a plant frame or just like community composition data in general, each of the plots were entered in separate files. So I had a bunch of Excel files that were all separated. So I wrote this function called import and merge file. We'll go and look at that. So I'll go to, that's in my R folder and it's in my package functions. And it should be the first one, maybe. Let's see. So this is my, maybe that's why this didn't work. The thing that I did before, it might have not worked because I didn't put this annotation in. Because I didn't export it, which is interesting because it worked in the other situation. So this function, I'm not going to go through too much like how the code works, but basically what it does is I give the function a file path with a bunch of files in it, and all of those files have the same naming convention, but there's a different plot name in each file. So it could be like arches, trample, plot 1T, and they're all named kind of the same, but the plot is what differs. So it pulls out that plot information and it puts that and it merges all the files into one. Does that make sense? The purpose of it? I don't want to get into like getting into how I made it, that's like a whole other coding thing. So here what I have is the file path to all of those files. All the Arches CryptoFrame files are here. So I'll run that. And then in my environment, you'll see, okay, this is a directory. And then I'll say file vector. This will list all of the files with the pattern interspace and then the directory. So now I have this file vector. We can look at what exactly the code is doing isn't that important, but I don't want you to get so confused. But so these are all the file names. So you can see I have 1C, 2C, but they're all separate files and I just want one object. And then I also have this problem where people put trace values in with T's. So they did that with like a capital T or a lowercase t or true, like all different types of things. So I also have to fix this true problem. So I wrote a function that basically makes all of the trues zeros so that I know that they're there, but they are all the same. Basically just, this is pre-processing. What I'm doing isn't that important, but the workflow is what I want to go over. So I have the files pulled in. The columns of interest are 3 through 18, so I let it know. I run my import and merge file, but it doesn't run because I haven't loaded my package. So I load my package and it's like, cool. This error is not important for right now, so you can ignore it. Cool, so I run it and the function prints, there are 19 observations in each of these files and it pulls them together. So now I have a data frame called df0, which has all the files as one. And so if there wasn't anything, it was a blank, so it was NA. But then I still have this true problem where there's a bunch of different types of T's. And so the abundance data is not numeric because of that. So I want to change all of those traces, T's, trues, T's with a space, as you can see right here, to be zeros. So I'll run that function. It works. Now, if we look at it, we'll see I think there were some T's in this in some of these columns. Well, there definitely was, and they're not there anymore. So those are just two functions that I wrote, and they are both in this package function. And the reason why I wasn't able to get it to work before in my demo was because I didn't put these two lines of code in. So you have to put, if you're making a function in your functions file that's in your R folder, you have to end it with a £, and a single quotation, describe in, this is package functions. It fixes the true and T problems and makes columns numeric. And then I export the function. So I do that first and then I write the function. And that way, when I build and reload my package, it knows that that's a function. So that's what I was messing up before. I just forgot a step. And here is just like a test function. I made this when I was like, how do I set up functions? So here it's just like this function. If I run test function 1, it will just print this is a test function. And it knows that that's there because it's part of my library. So every time I add a function, I would do the document command, and then I would do the build and reload. So now that we go back to my environment, I've fixed these 2 problems, and I rename, and I have this data frame. It's called DF0, but I want to name it Arches Crypto Interspace. So I rename it, and then I run this use data, and it's like, okay, you have overwrite set to true. We're setting, this is the project directory. We're saving it in data as a RDA. You need to document your data to see it. So then I'll do I won't do that there. I'll do document, and it will update the documentation. But really, before I do document here, because I didn't actually write any documentation, I'll go into my R folder, and then I'll open that data.r file. And you'll see the first thing in this data.r file is my Arches Interspace crypto frame. And I'll have description. This is crypto frame data from all of the plots in the interspaces at the Arches site. The format, this is a data frame with 20 columns and 120 rows. The rows are crypto frames that are nested within plots. The author is me, and the name is, this is the name of the object, and then it's in parentheses. And so then if I wrote that out, I type document, it will update the document. Then I would go to build and reload. And I see there's a question. Let me open the chat, or there's something in the chat.
It's just a thank you.
Oh, okay. So that's the workflow to, and so usually what I'll do, it's backing up. I'll show you in a second. So usually what I will do is I will, I have this initial data organized, which will be my first pass with the raw data, which will be things like, you know, making them all one file and fixing data entry issues, like if there's weird spaces and stuff like that. And then if we go into, if it lets me do anything. Come on. Are there any questions while we wait for my computer to let me do stuff?
I have a question that, I'm sorry if this was like really, really obvious, but how is this interacting with GitHub? Like in our last one, seeing that everything was being committed and pushed, like, is this, how is this interacting in real time with GitHub, or is it not? And that's like a post thing. It's
not interacting in real time with GitHub. You just have to do the GitHub process the same way you would do it.
Okay.
So it has a git ignore. It's like, just like when you make a package and you like check the box to, I mean, sorry, when you make a project and you check the box to, I'm gonna just try terminating my R session really quick and see if that fixes it, because it's taking too long. You just have to do git commits and pushes as you normally would.
Okay.
It just puts the whole package up there so someone can download it and they'll have all of your data objects. You won't be like, let me send you my project and let me send you like all of my, so my raw data isn't up on GitHub, but all of these data objects that exist within my data folder are up on GitHub. So if people want to take this data that we just went through, which is just like really preliminarily cleaned, and do stuff with it, they can.
Okay. Thanks.
I'm just gonna try quitting the R session and see if that fixes this issue. my computer doesn't like when I have Zoom and R running at the same time. And I just got a new computer for work, but I was nervous to use it because I got it yesterday. So I was like, what if I use it and none of my stuff works? So sorry about that. Okay, we're gonna try. Okay, I'm reopening it. Hopefully it will work now. So one of the things I've really liked for this project about using this approach is we ended up finding I found some data entry errors, and we had to like update some of the raw data files. And it was really easy for me to just rerun like each of these scripts and rerun this part and know that it's going to work, and then rerun the next thing and just get it all the way back through my pipeline really quickly. Okay, so now we're back in. I'm just going to load this library so that it doesn't get mad at me. So I usually, if I'm working in a package, I usually have just like you load the libraries you're going to use, I usually load my library at the top of every script. So this was like my initial clean. And then if we go, I have another script called make variables. These scripts are all written in what's called snake case, and that's lowercase, and then there's an underscore in between everything. It's a little bit different than camel case, but that's one of the ways I differentiate between functions and scripts. So here, the first thing I'm doing is I'm loading that data object that we just created. And basically the way that works, so I call it and it'll be in my environment as a promise. And then I wrote this, I just like subsetting and getting some information. I wrote another function that should be in my R folder. We won't go through it too much, but what it does is basically, because all of this data right now is just like raw frames, like if you've ever done a bunch of plant frames in a plot and you count where all the pin flags drop. I know we have a lot of soil people here, so maybe they are not familiar with that. But basically, I want to get the data to be at the plot level. So I wrote this function, it's written here. And basically what it does is it calculates the percent cover at the plot level. And so in my make variables script, I am running that function on this data frame, which is all of the plots appended together. In the data frame, it has the plot, the transect, which is where each of the different frames were measured, all of the different groups, both like biotic categories and then some abiotic stuff. And I want to get like a plot level value. So I run that, and then I added some site information and just some treatment information. And then I use data again to create this data object. And as you scroll down, you'll see once I create the data object, then I write all this information out. I type document into the command line, and I do the build and reload. I'm mostly going through this just so that the workflow is very much in your brain. So yeah, so I have these two scripts that they kind of make the data frames, data objects that I'll use for all of my analyses. And then the other stuff in here I have all my figures, and pretty much each of my figures starts with loading, not that one. I guess it does there. Starts with loading one of my data objects that I've created. Okay, so main things here, all of the scripts are in this exec file. I also have like a folder of saved models because I didn't really want to make those data objects in my package for whatever reason, but you could, and then you'd annotate and put, more metadata around them, and that would probably be a better way to do it than what I did. But then we're going to talk about one other folder or one other file in my exec folder that I think wasn't in the presentation and wasn't in what we did with the last example, but I think is really important. It's called a master script. And I save it in the exec file. And basically what it does is I source each of my scripts. When I save them, you can check this source when save. And then when you save it, the source, it'll try to run it, but it got mad at me. But the source, like the file path will be there. But so every script that I have, this is basically just a documentation of my whole workflow. So it says, this is the packet, this is the paper, and this first script, this is what it does, this is where it is. This second script, so this is the script we went through that does the initial data organize, and I have written here, this script aggregates the data file. I can make it a little wider so we can read it, maybe, potentially, if it gives me the, maybe not. Usually it gives, aha. Okay. So this script aggregates data files into one data frame, and it replaces the T's/trues with zeros. These are the names of the output files, so that you know what comes out of the script. The next script is what I just talked about, where I made the plot level abundance. So I describe what that script does, and then I source the script. This is the script that runs figure 1A, what figure 1A is, and I do that for my entire workflow. And what I like about this is if a reader or a reviewer wants to go through what I've done and see where things are and dig it apart, it's way better than being like, here's my random R packet, R project, figure it out. Like, here's my file convention. So this really gives someone a map of what you've done and why it's important. Cool. And I think that is all I have on sharing my package. If folks have questions or want me to show more of what I have here, I can. And I guess this is the namespace file that's generated by Roxygen, and it's correct, and it'll have like, it's exporting my import and merge file and some frame cover, which are the two, and the fixed true problem, which are some of the functions that we've talked about.
Michaela, I have a really kind of like general question.
Yeah.
So you mentioned just up front in the little presentation that you showed that, you don't have to go through this process of making packages, but it seems like it does a really good job of streamlining when you're working with data that you're maybe collecting over time, because you're going to have like similar file structure. But can you, like, when is it when would it be like good practice to be worth it to go through this process of making packages? Like, is it really advantageous for, a project where you are doing something over time and you're going to be collecting the same kind of data, so that these functions that you make are going to be really useful? Like, when would it not make sense, like, to make a package?
Yeah, I think that's a really good question. So my rule of thumb is, if it's going to be a paper for me, it's going to be a package, because then it's something redistributable that readers and reviewers can access and interact with if they so choose. So an example of when I didn't make an R package, one of our technicians sent me some data and asked me to run some ordinations for him. So I just did that in some scripts, and like, I don't even think I made an R project, and I sent that back. Another great application of this is, so these data that I'm using from our climate manipulation experiment here. That experiment's been running since 2005, and we have had a lot of different people come through, but me and one of our awesome technicians have been really trying to organize that data, especially since it's so long term. So I've been making an R package that just does some cleaning stuff for the plant data and puts it all in one place. So that isn't necessarily for one paper, but it's a way that myself and other people that come in can easily access that data, and it can be organized and standardized for whoever's running the project every year. I think like smaller things where like, you know, you're just making one figure, or like if it's for a class, there's no point. But anytime you're starting to do a big involved project, I can't really think of a better option that exists to organize your code in a way that's usable both for you and in terms of like thinking about reproducible and robust science that folks can check. Okay, there's a question that says, can we see what is in your README file? The master script contains info I would expect to see in there. And that's true. I mean, I could have just put, the reason I could put my master script in my README, but the goal is eventually that someone could run my master script and run my whole analysis if they updated the file paths. Because like clearly when they downloaded my package, it might not follow this exact file path. But one of the things I have in here that I have these Bayesian multi-level models, and if someone tried to run that script, it might take like a long time. So, but you could put those in the README. What I have in the README right now, and this is still under development, is just like basic stuff about the project. I probably will add a paragraph down here that talks about like what analyses I did and why, and what figures they're in. That way, for like a reviewer or something like that. Does that answer that question? I'm gonna take that as a yes.
Yeah, thank you. Appreciate that.
Okay, and another question. Can you share your sense of when a package should be on your GitHub versus actually put up on CRAN? This is a really good question. So this package is on my GitHub right now, but it's private, and me being able to publish it is going to be complicated because government stuff. But getting something on CRAN is actually quite challenging. It has to go through a pretty in-depth vetting process. But like my partners made some packages. One is like repackaging some of the FIA forest inventory analysis data that's on GitHub, and I'll just like install that off of GitHub and then use it because it's got functions in there that I like to use. But he doesn't really have an interest in like trying to get it on CRAN, just because getting something on CRAN is kind of it's an in-depth process, and you wouldn't. I mean, with that package, he could potentially want to, but with this package that I'm showing, because it's just for a publication, I'd never put the effort into putting it on CRAN. And yeah, I think Sharon says, obviously that's a question for packages that others might also want to run. So like if you get really into programming and you're like, whoa, I've made like the best functions for this type of analysis and I want other people to have access to it, that's when maybe you'd try to put something on CRAN. But you can also put it on GitHub, and people can install stuff from GitHub using DevTools. I think it's like install, no, it's DevTools install. Yeah, there's a install underscore GitHub. I forget what package it's in, but then you just put the web address and it will install it. Okay, there's another question. Do I only make packages when I include all the data? Is it still beneficial to organize your code, etc.? Like when you're using sensitive data that you couldn't directly include in the package? I'm not entirely sure I understand this question. This package has some data in it that I'm not using in the paper, and I could probably put out, like throw out. One of the things I like about having, like, it doesn't have the raw data, but it does have a lot of data and most of it's just like the initial clean data available. So it's an easy way to make your data available with your code instead of maybe you put your data up on like Mendeley data or some other database, where then if someone wanted to check your work, they'd have to go track down your data and your code. So I think if you have sensitive data, then maybe you could always make the package and not make it public. Like right now, this isn't public, it's on my GitHub, but it's private. It's on like my USGS approved GitHub. You could also, I don't have my raw data available in this, so you could just save data objects that are, aggregated in a way that you feel comfortable. I think those are your options there. And then there's a question about doing this with GitLab or with MATLAB. I've never used MATLAB because I work in things that are open source. So I don't know about MATLAB. And I think for ecology, I feel like R is kind of a good direction to move in because it's open source and you might get a job where you don't have the money for MATLAB. But that's just personal preference. I'm going to stop sharing my screen unless anyone has a question or wants to see anything in the in my package. And one thing I do have that I want to share before I forget is the post-workshop survey. I'm going to put it in the chat for folks to do. I hope this was helpful. I hope it wasn't too rambly. I use this a lot, but explaining it to other people is a lot different than existing in my mind. And that's the post workshop surveys in the chat.